Hello amigos, now let's continue with equation of trajectory and time period. Velocity, anomalies and other topics will be covered in next lecture. So let's start now. Equation of trajectory is given by r equals h square upon k square upon 1 plus e cos theta. H square, k square are known parameters which we have seen in earlier lectures, which can be represented in terms of p equals to h square upon k square, where p is semi-lattice rectum. And now we have this binding energy which is represented by h equals magnitude of kinetic energy minus magnitude of potential energy. We know the sum of potential energy and kinetic energy along with their corresponding signs or conventions is given by total mechanical energy, but the difference between their magnitudes is given by binding energy. If the kinetic energy is more than the potential energy of the satellite orbiting around the Earth, which will make the satellite escape from its orbit, then the binding energy will be positive, or say the satellite will escape from its orbit. Okay, and if its kinetic energy is less than the potential energy, then the satellite will be bound to orbit around the Earth or any other planet, which is why circle and ellipse have negative binding energy. H is less than 0. Now we will see from this table that these are the orbits with these equations: semi-major axis, eccentricity and binding energy. The orbit here is circle with its corresponding equation x square plus y square equals r square. Semi-major axis equal to r. Eccentricity is 0 because the center C of the orbit coincides with one of the foci of the circle, which is why C and F foci coincides with each other, which means C is 0, and E equals C upon A means eccentricity will be 0. Therefore eccentricity is 0 since orbit is bounded, h is less than 0. Semi-major axis is distance from center to the extreme point, and the extreme point for the circle is radius from the center, which is why A equals r. And similarly we can define these parameters for ellipse, parabola and hyperbola. For ellipse, semi-major axis A is greater than 0. As you can see, A has some positive value, okay, when measured from center to one of the extreme points, okay, and E lies between 0 to 1, okay, because C is less than 1, or say C is less than A always, so E always lies between 0 to 1, and bounded orbit, that's why h less than 0. For parabola, y equal to x square, or any equation depending upon the quadrant in which the parabola is. Similarly, depending upon the axis which is the major axis, we have this x square upon a square plus y square upon b square for an ellipse, okay. Similarly, for hyperbola, we have x square upon a square minus y square upon b square depending upon its major axis. And for this semi-major axis, for parabola, a tends to infinity, eccentricity is equal to 1 and binding energy is 0. That is why it's known as escape orbit. Parabolic orbit is trajectory is also known as escape trajectory, or that's why corresponding velocity to this parabolic trajectory is known as escape velocity or parabolic escape velocity. And if the velocity is greater than this parabolic velocity, then the satellite follows the hyperbolic path given by this equation. And velocity, parabolic velocity, as we know, is minimum escape velocity, okay. And a for hyperbolic orbit or trajectory is less than 0, and E eccentricity is greater than 1, and since velocity or kinetic energy very high than the potential energy, which means H will be positive or binding energy will be positive. Now we have this eccentricity, E equals 1 plus 2 h square h upon mk raised to power 4 whole under root, and it's given in terms of center C and A, semi-major axis, and in terms of RA and RP. RA is the distance from one of the foci to extreme and one of the extreme end, which is the larger distance, okay, and RP is the distance towards the extreme end with the shorter distance, and RA plus RP divided by 2 gives us distance A. And in terms of A, we can define E equals C upon A, or C equal to AE, and this is given by definition of ellipse: A square equals B square plus C square, okay. And for theta equals 0, that is distance R, if distance R is represented at an angle, then trajectory is given by this equation. If we have R as a distance from this point to that point, then the theta is given from the perigee or the horizontal, okay, and we can substitute that theta over here. But if theta tends to 0, then R will tend to RP, which is distance from this foci to this P point perigee, and RP is given by P upon 1 plus E, okay. P is this upon 1 plus E because theta is 0 cos 0 1. Similarly, for theta equal to 180 degree, we have RA, okay, and RA is P upon 1 minus E, cos 180 is minus 1. And in terms of semi-major axis, RA is equal to A into 1 plus E, and this RP is equal to A into 1 minus E. And the area of ellipse is given by pi times AB, or say pi times A multiplied by A under root 1 minus E square. Here we have time period T to, for a satellite which is revolving around a planet in elliptical orbit is given by 2 pi AB by H. And for any satellite which is orbiting around a planet in any type of orbit, whether it is circular or parabolic, it can be defined in terms of R, like 2 pi r raised to power 3 by 2 by k, because T square is directly proportional to R cube, which can be seen from this expression as well. So thank you, and we will continue in next lecture now.